So if the question was, do this long division, right? You would lay it out in this form, and you're taking this guy and dividing this guy into it. So when it comes to long division, the way you end up doing it is, the only thing you care about is matching the first guy in the dividend to the first guy in the divisor, the first guy in the numerator to the first guy in the denominator. So what we should be asking ourselves is this: what do we multiply x by to give us negative 3x squared? It's the same thing that we had when we had 27 here and 2 here. What were we going to multiply the 2 by to give us the first number 2 in 27, right? So what we multiply x by to give us negative 3x squared is negative 3x, right? And what we do with that is we put it up top, the same format that we had for integers, right, when we're dividing integers. So what we're going to do is put negative 3x up here and multiply that out with these two terms and write them down here. So what we do, we put negative 3x up here, and negative 3x multiplies the x, and then it multiplies the 5. And again, we definitely want to match the sign of these numbers too, right? That's a positive x, and that was a negative 3x squared. So we need a negative number there to turn it into negative 3x squared, right? So negative 3x times x is going to be negative 3x squared, which is exactly what we wanted. We want to match it, right? And negative 3x times negative 5, negative 2. I'm looking at it backwards, so it looks like a 5. So negative 3x times negative 2 is going to be positive 6x. Now, what you're going to do is subtract this from the above term, okay? So usually the way it's taught in most places that I've seen, they go minus this, and then minus that from those two terms, and they go negative and then negative equals a positive, so you add those guys and they kill each other. I don't like that because I lose track of my signs. So the way I like doing long division is, what I do, as soon as you do your multiplication, and trust me, this makes life a lot easier, because that way you don't have to worry about a negative and a negative, right? Because again, long division, this is a fairly simple one, it's a short one. But for long ones, you're going to have a lot of, there's going to be a lot of things you need to keep track of, right? And the last thing you want to keep track of is, when you have a negative and a negative, so it turns into positive, and then you do your, addition or whatever it is that you're doing, right? The simplest way to do it, I like adding rather than subtracting. So what I end up doing is, if you're subtracting the bottom from the top, all it means is you're changing the signs of the bottom and adding it to the top. So as soon as I do my multiplication here, lay down my terms here, what I do, I change the sign of all the terms in the bottom and I add things together. So what I end up doing is changing negative 3x squared to positive 3x squared, and I'm going to add it to the top. The top is negative, so negative 3x squared plus 3x squared is going to be 0 in the bottom. That's 5x plus negative 6x, instead of going 5x minus 6x, right, is going to be negative x. Now what you do is, just like you're, dividing numbers, dividing your integers, you're going to grab whatever is over here and bring it down. So you grab the 2, bring it down. Now what you're looking for is the question you should be asking yourselves, and this should become automatic. It should be something that, as soon as you get to the next line, this is the question that should be, clicking in your mind is, what do you multiply x by to give you negative x? And the answer to that is negative 1. So what you end up doing is putting negative 1 up here, and then multiplying it out through this guy, and then multiplying it to the other term and writing it down here. So you go negative 1 times x is negative x, you're going to write it down here, and negative 1 times negative 2 is going to be positive 2. So you have negative 1 times x is going to be negative x. Negative 1 times 2 is going to be positive 2. So what I end up doing is changing the signs in the bottom over here and adding these things together. So that was a negative x, it changes to a positive x. And that was a positive 2, it changes to a negative 2. So negative x plus x is going to be 0. Positive 2 minus 2 is going to be 0. So we just got down to 0, which is basically telling us that this guy divides evenly into that guy. Another way you can think about it is, as soon as you get a remainder of 0, it means that this guy is a factor of the top guy. Okay? And going back to our terminology, the symbols that we're going to call each one of these things is the following. So what we have from our division statement is the top guy is q of x, is the quotient, right? X minus 2, this guy is going to be our divisor, d of x, which is that guy right there. This guy here is our numerator, or our dividend, but we're not going to call it big D, we're going to call it p of x, because it's the product of things multiplied together. Okay, which is really what we're looking for, right? And, you know, it splits up the terminology so we don't have two different d's in our division statement. Down here is our remainder, r of x. Right now it equals 0. And whenever the remainder is equal to 0, it means what you were dividing is a factor of the top. And this is super important because it's what we're looking for, right? So we're going to write out our division statement and then write these out, and you're going to see how everything fits together. So our division statement is the following, right? P of x is equal to q of x times d of x plus r of x. So what that means is negative 3x squared plus 5x plus 5, p of x is equal to q of x, right, which is the quotient, whatever we found out here, times d of x, which is x minus 2, plus r of x, which is 0, right? So right now, we have our division statement, and the above you can write in the following form. We're going to do a way more complicated version of this, or more complicated version of this, a longer one, where the remainder does not equal 0, and where we're going to have an r of x. And again, that r of x is just going to be our y when our x, you know, you set this thing equal to 0, where our x, when you bring the number over, x equals the opposite sign of this, then if you sub that x into our original polynomial, that's going to be your remainder. Now we've talked about just, you know, factoring the polynomial, breaking the polynomial down to those prime factors, I guess, prime polynomials, right? And whenever you get a quadratic, you should right away look at it to see if you can factor it, right? Using all the different factoring techniques that we've learned so far: simple trinomial, complex trinomial, quadratic formula, difference of squares, or even GCF, to see if there's a GCF that you can take out, and maybe that GCF kills your denominator, right? Now the top guy we've already factored using two different techniques, and its factors are the following. So what you would end up having if you factored that guy straight out using either complex trinomial factoring or quadratic formula, you would get the top guy is equal to x minus 2 times negative x minus 1, right? Divided by x minus 2. Well, x minus 2 kills x minus 2. So if that guy kills that guy, what you're left with is negative 3x minus 1, which is what we had over here, right? Final answer would be this guy. So again, right now, learning those two techniques, complex trinomial factoring and quadratic formula, it's given us two other choices for us to do this problem, right? And the way that's sort of the way it works in mathematics. The more tools you have, the more ways you can tackle a problem, and the more power you have, right? So there are easy ways to do things, and there are harder ways to do things. It's up to you which way to solve a question, to answer a question, right? And the more of these things you do, the easier it's going to become for you to recognize which technique to use on which type of problem. Okay. right? And this is exactly what we're doing right now. We're taking our toolbox, putting a whole bunch of different tools in there, techniques in there, to be able to attack problems from multiple angles, because sometimes it's a lot easier coming at it from this side than it is coming at it from the other side.